one. There you go.
And we can pause.
Yeah, it's okay. No, it's good. So my problem is that people draw hexagons everywhere. Hexagons don't exist in the code. They're not real. People draw lines. Lines don't exist in the code. They're not real. So what I'm battling against is people just literally drawing hexagons everywhere and said, I did it. And they go, no, you didn't. And then I have to ask, of course, why? How do I know you didn't do it? What is it you didn't do? Well, the first thing is they don't put tests there. If you don't have tests, you have no protection. So the hexagon is really what we learned recently is a component. In the UML sense, it's a component. Like if you get a chip from a catalog, right? What are the characteristics of a chip from a catalog? It's got input pins. It's got output pins. You, the user, don't get to choose what the output pins output. It tells you. And by the way, they test it in the factory. So the two characteristics are the chip owns the interface and they have tests. So when I look at a piece of code and they say, they draw the line, I have to see that the thing owns the interface and they have tests. Well, now we get to the question, this was the question, what is the difference between merely an interface and a port?
Which is a special kind of interface.
Which is something, an interface plus something.
Right.
And the reason, the background is that this colleague of mine, I have high respect for him, drew an architectural picture, wrote a blog entry, and he had where I would put the hexagon next to the technology, the real technology boundary, and he drew it inside at the bounded context in DDD terms.
So inside the component?
Inside what I would call the component, he declared that the bounded context was a component, or it was a hexagon. He said it's a hexagon. Hexagons have no meaning, but that's what he said. So the test question I asked him, I said, well, I foresee a problem that you have to write tests around your hexagon, and you also have to write tests actually at the technology boundary. You've got a team of people, I can't imagine they're going to maintain all of those tests. And he said, no, they only maintain them at the technology boundary. And I said, your inner thing is not a hexagon, in the sense I mean it. It's not a component. It doesn't have tests. It's nice, but the line doesn't mean anything. So then I had to face up to the question, if I look at code, how do I know if it is or it isn't? And so the test question...
Is or isn't?
Doesn't or doesn't implement the ports and adapter architecture, to use the long words very correctly. Right?
Good.
Is or isn't a hexagon, loosely speaking, but really implements the ports and adapter architecture.
Right.
That means it has to have ports. So now we're at the how many angels dance on the head of a pin question that I was asking those people, what is the difference between an interface, merely an interface, and a port?
Which is also an
Which is an interface plus something. What's the plus something?
Right.
So that was the test question I gave them, because I have to face it. It's a great question. Nobody knows it because it's not a question that gets asked, right? So I don't even have the perfect answer, like I'm noodling toward it. But I used a chip analogy. Now there's two characteristics of the chip. The chip manufacturer owns the interface. Okay. So if we look at Java, turns out to be perfect for expressing this, and we have a package diagram or something. In an ordinary kind of a system, you have a component. I'll use the glass as the component, right? And this is a boundary. And the other thing on the outside declares an interface. And the writers of this wine glass...
This is the component.
That's the component, is the wine glass. The writers of this component, of this wine glass, have to code to the interface of the wine bottle, of the external thing. That's normal, right? If you get a database, you have to code to the interface the database provider told you.
Okay.
So we modify...
Because the database existed first.
Exactly. It came from a catalog. You can't change it. It's there.
Okay.
Doesn't matter. HTTP, database, file system,
Yeah.
anything, right?
Yeah.
You bring in a thing, it owns its interface.
Yeah.
You have to modify your code to meet that interface. This thing has an interface. That the calls it makes out are the outgoing interface. But these people have to meet the requirements of the what's called provided interface of the thing on the outside.
So maybe SQL, for example.
For exactly. What's different in order to make it like a chip? This thing has to own its own interface.
The caller.
Yep. The caller, the wine glass in this case, declares the verbs it will use to call out.
Right. This is the subset of SQL I'm going to use.
I'm not even going to use SQL. I'm going to speak in my own language. I don't know if SQL is there or not. There might be no SQL. There might be a flat file. There might be a human. There might be a UI.
I do whatever I want here.
I do. It's very godlike. It's very haughty. I mean, it's really, really egotistical.
Could be, yeah.
It says, I will only talk to the rest of the world. In this way, if you want to deal with me, you must honor my language.
Yes.
Right? That's a port. That's the part of the port, like a chip. Right? So you make a component like it could be in a component catalog.
Can I clarify the recording?
Yeah.
We've got two components. One is the caller, the wine glass, and the other is the standard thing from the library, which is
the wine
a chip,
bottle in this case.
the wine bottle, and which could be a chip or a SQL database.
And now, guess what? Because each of these has declared it owns the vocabulary.
Yes.
And they're different.
Yes.
Guess what?
Now, I did not understand that back
So
then.
guess what? You have to put an adapter between them.
Adapter. Right.
That's where the adapter comes from.
Got you.
Is because this thing, your system, declared, I will only speak in my terms, which is a domain-driven term. There's no reference to technology. I will say what I want.
Business and domain.
And somebody, you have to integrate it with somebody else's thing where they did the same thing.
Yes.
So you need
from
to
a
write,
technology point of view,
right?
on the right-hand
And
side.
so you have to write a
An
translator, an adapter.
Right.
So the thing is, if now let's go to a Java packaging diagram or Java whatever diagram.
So more strongly typed.
Yep, because Ruby, it's so soft, this discussion almost can't exist, right? It almost doesn't exist in Ruby because there's no declarations of anything, right? You just do stuff. But anyway, for Java, so normally we would have the technology thing, the external thing, and we would have that it declares an interface, and we would have that this uses, with a dashed line, uses that interface.
The dashed line being without the adapter.
Without whatever, yes, it will. The programmers here will adjust their code to meet whatever the external thing set, like SQL being a perfect example, right? Where was I going to go with this? One second. Let me just catch up. Now what we're going to do is we're going to say move that interface. This interface is defined by the external thing, right?
Yeah.
We're going to move the interface definition inside the component.
Inside the business component.
Inside our thing, right?
Custom thing.
So this thing now declares an interface, and UML calls that a required interface.
Required interface.
So this is a provided interface. Is the normal calling interface that we're used to,
such as the SQL one.
Yep. And provided is in Ruby you can't even see it. It doesn't exist, right? It's just with these make calls.
You could have a comment or something.
Yeah.
But
you wouldn't see it. But in Java, you literally can say, this is the interface I'm going to use. And you declare the interface.
Right.
And then the uses relationship is internal to our little thingy.
Right.
And now we have this thing, and they do this little vertical arrow, right, with the big triangle head there. Yeah. This implements that interface. In this case, our adapter implements this interface.
The required interface.
Yes. And uses the provided interface of the I'll say SQL just to be
the technology,
the SQL, right?
Yeah.
That's why we have to have an adapter.
Yes.
But notice that our thing owns that interface.
Owns the left-hand side interface.
Owns the definition of the interface, and anything that wants to talk to us has to do and implements that. Yes. So when you look at the package dependency, right, the external thing has a package dependency on our component,
Yes.
Whereas if I didn't have the adapter and we were doing it the other way,